In this lesson, we will learn why certain objects sink or float. Whether an object sinks or floats in a fluid depends on its buoyancy, expressed as the buoyant force. The buoyant force is the upward force exerted by the fluid against the weight of the object immersed in it. The basis for this is known as Archimedes' principle. Archimedes was an ancient Greek mathematician, philosopher, physicist, engineer, and astronomer who lived in Syracuse on the island of Sicily. Archimedes is believed to be the first to discover how to measure the volume and density of an irregularly shaped object by the displacement of water. Archimedes experimented with water displacement to develop his famous principle, which states that the buoyant force acting on an object in a fluid is equal to the weight of the fluid it displaces.
Take a soccer ball and place it in a tank of water. It floats because the force of the ball against the water, due to its weight, is less than the buoyant force acting on it from the water. Now drop a bowling ball into a tank of water. It sinks because the force of the ball against the water, due to its weight, is much greater than the buoyant force acting on it from the water.
We can prove Archimedes' principle using water as the fluid. We know that density equals mass divided by volume, which is the same as volume times density equals mass. Since the density of water is 1 gram per cubic centimeter, using this equation we can calculate that 1 cubic centimeter of water is equal to 1 gram. 1 cubic centimeter is also equal to 1 milliliter, so therefore, 1 milliliter is also equal to 1 gram.
We can measure the buoyant force on an object that sinks, by adding water to a large graduated cylinder to about the halfway mark, and recording the volume of water as V subscript I. Now take a 200-gram steel weight and drop it into the cylinder. Notice that the water rises. Read the new volume on the graduated cylinder, and record it as V subscript F. Now calculate the displaced volume of water V subscript D by subtracting the initial volume V subscript I from the final volume V subscript F. The volume of water V subscript D is the same as its weight, which we can use to calculate the buoyant force.
In order to calculate the buoyant force, we must convert the weight of the displaced water into the standard unit of force, newtons. The weight of the displaced water is 150 grams. There are 101.97 grams in 1 newton, so if we divide 150 grams by 101.97 grams per newton, we obtain a buoyant force of 1.47 newtons. The force produced by the 200-gram weight is calculated by dividing 200 grams by 101.97 grams per newton to give a force of 1.96 newtons. Since the force of the object is greater than the buoyant force, it sinks.
To find the buoyant force of an object that floats, we add a measured amount of water to a large container using a graduated cylinder. Record the initial volume of water as V subscript I. Place a small, 9-ounce plastic beverage cup into the water in the container and note that it floats. These cups typically have a volume of about 250 milliliters of water. Now place a glass rod in the center of the cup and push down gently until the brim of the cup is about even with the water level. Place a mark on the container at the meniscus, where the water rose to its highest level. Remove the cup and pour all the water out from the container. Add a measured amount of water from a graduated cylinder to the container, until the level reaches the mark you made on the container. Record the measured amount of water added as the final volume, V subscript F.
To calculate the buoyant force, first calculate the volume of the displaced water by subtracting the initial volume, V subscript I, from the final volume, V subscript F. Because the density of water is 1 gram per cubic centimeter, or 1 gram per milliliter, the volume of displaced water in milliliters is equal to its weight in grams. Now convert the weight of the displaced water in grams, to newtons to obtain the buoyant force. Remember that 1 newton is equal to 101.97 grams. Measure the mass of the cup in grams, using a triple beam balance. Convert grams to newtons, to calculate the force that the cup makes on the water. The cup floats because the force created by the cup is much less than the buoyant force.
Density is also important in determining whether an object will float or sink. Objects that have a lower density than the fluid it is immersed in will float. Objects that have a higher density than the fluid it is immersed in will sink. This redwood block floats in water because its density is much lower than that of water. The steel block sinks because its density is more than 7 times higher than that of water. The can of Diet Coke floats because its density is about the same as that of water. This can of regular Coke sinks because its density is higher than that of water, due to the high concentration of sugar in the beverage.
Another important factor is the shape of the object. An object with a density greater than water can float, if its shape is changed. We can prove this by using a sheet of aluminum, which has a density of 2.7 grams per cubic centimeter, higher than that of water. Cut a sheet of aluminum foil, and carefully place it on the surface of water in a tank. Note that the foil floats, because of its large surface area. Now remove that same sheet of aluminum from the water, dry the bottom with a paper towel, and crumple it up into a small ball. Drop the ball of aluminum into the water. Note that the crumbled aluminum ball sinks because its surface area has been greatly reduced. Steel has a density of 7.6 grams per cubic centimeter, much greater than water, yet a steel ship floats because of its shape. The ship is shaped in such a way as to have a large volume so that it displaces enough water to create a buoyant force that is much greater than its weight. Ships are often specified by the weight of water that they displace. The USS Ronald Reagan is one of the world's largest steel aircraft carriers. It displaces 92.5 million kilograms of water, equivalent to a buoyant force of 92.5 million newtons. This is much higher than the weight of the ship when it is fully loaded with the crew, aircraft, and equipment. In summary, an object floats in a fluid when its buoyant force is greater than its weight. The buoyant force acting on an object is determined by its volume. Density and shape are also important in determining whether an object will sink or float.
This presentation was produced as a public service to help middle school and high school science teachers develop experiments and demonstrations that can be used in their classrooms. Teaching Opportunities for Partners in Science, known as TOPS, is a program aimed at stimulating greater interest in science by middle school students. More science experiments and demonstrations are available on the TOPS of Santa Clara Valley website, www.topsofscv.org.